Okay, so this is our last lesson of the quarter. We're talking about light and the electromagnetic spectrum. So take out your Cornell notebook, go ahead and get this information in there. And so this is what a light wave looks like. What it is it's made out of two waves. It's going to be an electric field wave and a magnetic field wave. And what's happening is the direction of the electric field and the direction of the magnetic field are changing over and over again, creating this these two waves really that are perpendicular to each other. In a vacuum, the speed of light or the speed of any electromagnetic wave is going to be 300 million meters per second. So very, very fast. So specular and diffuse reflection, we're going to be talking about different aspects of light and how they act and how we interact with light, starting with reflection. So specular reflection is perfect reflection. It's what you see when you look into a mirror. And the image isn't deformed. You can see clearly what is being reflected. And the law of reflection is that the angle of incidence that the light comes in at is also how it's going to bounce off. So when you hold a mirror to the side, you can see things that are kind of in the opposite side of the room. If you are driving around, you're using your side mirrors in this sort of way where you're able to see not what is directly in front of the mirror, but kind of what's off to the side. In diffuse reflection, the image is not reserved. So all the light that comes in and hits the object bounces off, but it gets scattered. Therefore, the image isn't there anymore. All the colors are bouncing off in different directions. And what you end up with a lot of times is just white light. So here is an image to kind of show you what I mean with the specular reflection. It comes in and it's going to bounce off. If I drew an imaginary line right here, the angle between that imaginary line and the incoming light is going to be the same as the imaginary line and the outgoing light. So it perfectly bounces off. With diffuse reflection, it comes in, but then you notice that it's bouncing off in all these different directions, getting all jumbled up. Example of specular reflection is going to be water. Still water makes a really good example of specular reflection. The water acts as a mirror, so you can perfectly see the reflection of the mountains here and the reflection of the trees. Diffuse reflection, snow is a really good example of diffuse reflection. So you have light coming in, bouncing off of the snow, but it's getting mixed up. So all you're able to see is white. You don't see the sky or the clouds or anything bouncing off of the snow here. Refraction is going to be the changing of the speed of the incoming light depending on what it goes through. So in a vacuum, the index of refraction, how much it refracts, is 0 or is 1, right? So it's not bending at all in a vacuum. When it starts to come through the air, the light is actually going to bend slightly, change speeds slightly, slow down. In water, it's going to change speeds even more. So refraction is the changing of the speed of the light depending on the material that it's going through. So an example here is glass. You can see that it's moving, the light is moving through the air, and then it hits the glass here and it changes speed. When it changes speed, it's going to change direction. And then when it comes out the other side, it's going to continue moving at the same speed that it was on the other side of the glass. This happens a lot if you ever are going to go spearfishing or if you ever see a fish in the water. What you're actually seeing is an imaginary fish over here. This is where it looks like it's located, but because of refraction, the bending of the light as it's going from water to the air, the actual position is here. So if you're a spearman and you're throwing a spear, you wouldn't want to aim here. You would want to aim behind the fish. Okay, we're going to stop there for a moment and then come back and talk about our last aspect here, diffraction.